At the annual meeting of the American Statistical Association in 2014, a speaker posed a series of questions and answers. Question: why do so many colleges and grad schools teach P equals 0.05? Answer: that's because that's what the scientific community and journal editors use. Question: why do so many people still use P equals 0.05? Because that's what they were taught in college or graduate school. Obviously, the point is that significance tests have become so commonplace that nobody even thinks about whether they're meaningful or useful. These are just ritualistic traditions. Studies by Scott Armstrong have shown that MBA students, researchers, and the public at large often misinterpret statistical significance tests. The logic of statistical tests is very tortured. Start by stating null hypotheses that you believe are almost certainly incorrect. Then analyze your data on the basis that the assumption that these incorrect hypotheses are in fact correct. If the analyses based on the incorrect hypotheses say that the data are unlikely, infer that the null hypotheses are truly incorrect, which is what you assumed. Now, is it significant that data contradict incorrect assumptions? Isn't it very likely that if you make incorrect assumptions, the data will contradict you? Although researchers and the public want to treat significance tests as saying something meaningful about the correctness of hypotheses, the tests do not actually test hypotheses. Researchers want to test hypotheses, but the tests test data. The tests estimate the probability that the data are consistent with the null hypotheses. They assume that the null hypotheses are true. There's no evaluation of the null hypotheses whatever. Almost all null hypotheses require very high precision. They do not allow for approximations. For example, one hypothesis might be that two averages are exactly equal, and when they say this, they mean equal up to many decimal places. They do not mean that the two averages are similar in value. Another alternative would be, in regression analysis, the assumption that all of the independent variables have exactly zero effects on the dependent variable. Not weak effects on the dependent variable, but zero effects on the dependent variable. It was this dependence of statistical significance on sample size that first made me skeptical about the use of statistical significance tests. I read a mathematical theorem that showed that as the sample size goes to infinity, it is certain that every test will produce statistical significance, even if all the null hypotheses are true. That is, if there are no effects at all in the data, the calculations will find effects in the random errors. It seemed to me that this was saying that the importance of phenomena depended on how hard researchers worked and not on the phenomena themselves, and that made no sense to me. It is widely believed that journal editors will not publish research papers that do not report statistical significance. And there's evidence of this behavior. An implication seems to be that researchers go to great effort to declare that they have found statistical significance, even if that involves various other manipulations. But this whole idea that you have an analysis that requires statistical significance, and that statistical significance is this clear-cut, yes, no, we found it or we don't have it effect, doesn't fit with the nature of research. The research that most people do involves some sort of sampling. They don't have entire populations. And when there are sampling errors, the implication is that other samples from that same population would produce somewhat different findings. So you don't need analyses that say there are or are not effects. You need analyses that say more. The analyses ought to say, what are the likelihoods of effects of different sizes, given the data that you have so far?